Okay, a quick recap of some of the topics of class 11. So first topic is SHM, and in which I'm interested in equation of SHM. So if its derivation is asked, then student can make use a uniform circular motion. uh, there is a circle center A, particle is at point A, and then sorry, at point P, then it reaches point Q, and radius of this circle is A. Purposely it is taken as A, and it has traced some angle theta, and coordinates here are x and y. It means if we draw a projection over here, this is y, and from here to here it is x. I'm interested in y only. So, and this particle is moving with constant speed but variable velocity. I'm not going to explain why is it so. We are interested in its angular velocity. So consider a particle performing uniform circular motion, so, with the angular velocity omega. So omega equal to theta upon t, so theta equal to omega t. Later on we will use it. Now we'll apply some trigonometry formula here. So sine theta in this diagram is y upon a. That means y equal to a sine theta, and theta, and theta is actually omega t, so y equal to a sine omega t. So this is a general form of simple harmonic motion, and it relates displacement with time. And if we draw its graph, it goes like this. After one complete round, uh, it will be called one cycle. It will take time equal to t, that is time period, then 2t, then 3t, and so on. So, and this is the maximum displacement here. Displacement, this is the maximum displacement, which is a as amplitude, here minus a. So in the same way, this equation can be in the form of sine omega t or in the form of cos omega t, and in fact the combination of both. Means I'm not saying that this can be written as this, but I'm saying that the equation of simple harmonic motion, actually yt equation, displacement time equation of simple harmonic motion, can be given as y equal to a sine omega t, as well as in some other case it can be cos omega t also. It can be sine omega t plus cos omega t also. So this SHM yt relation between y and t must be linear. Means simple, a linear, this is a linear relation, and means it should not have some powers. So this must be linear, and with the single frequency term. Means if I would write a sine omega t, it's correct. If I would write y equal to a sine 2 omega t, it is also correct, because in it there is 2 omega t, but for this equation it is a single frequency for this case. But if I would write a sine omega t plus a sine 2 omega t, now there are two different frequency terms, so this is not be considered as simple harmonic motion. And but y equal to a sine omega t plus a cos omega t, it will be considered as simple harmonic motion, because it is linear and the term here has single frequency, means that is omega. If we expand this, we will find 2 pi nu. Okay, omega, one more thing, omega is theta by t, as well as 2 pi nu. Nu is frequency. or 2 pi by capital T. T is time period. Okay, if this is the displacement time equation, so its graph, yt graph will go like this. And if they ask about velocity of particle, then velocity will be dy by dt differentiation of this. So it will be d by dt of a sine omega t or cos omega t, whatever you have considered. So now a simple rule for differentiation: a is constant, differentiation of sine omega t is cos omega t, but there is some omega term extra. We will write it as a bonus. Why is it so? We are not getting into it right now. You will understand it later, or just trust me, and this is what the differentiation goes like. Okay, a sine omega t. If it would be only a sine t, then answer would be a cos t, but it was a omega t, something else. So therefore this differentiation has this rule. Later on you will come to know that it is called chain rule. So don't trouble yourself thinking this. Okay, so it is a omega cos omega t, simply v equal to this much. If we want to draw a graph for this, if we want to draw vt graph, so this is a cos graph. At 0 it has maximum value, then it goes like this. Okay, here 1/4, 1/4, 1/4, 1/4. This is complete one round trip, and it will take t time. But here amplitude is actually the remaining part. Remove this cos omega t term, so the remaining part is amplitude. Here in the case of displacement it was a. Remove this part, remaining is the amplitude. So here remove this part, remaining is the amplitude. So this is a omega, so negative a omega also exists there. Okay, and if we want to find acceleration, then it is dv by dt. So d by dt of a omega cos omega t, and now a omega is constant, then cos omega t, that bonus constant, so it will be omega square, and cos, integration of cos is minus sine omega t. Remember, differentiation of sine is cos, but differentiation of cos is minus sine. And if we want to draw graph for this acceleration, it will go like this: a t, and it is negative of sine graph. And once again, this is after one complete round trip, it is t. Actually this t is a variable, it will go on and on and on. This is t, time period t, and then for next round, then for next round. Here the amplitude is this a omega square term. Here it is a omega square, here it is minus a omega square. Why I have taken it from downward? Because it is minus sine omega t. Earlier this was a sine omega t, so it went up and then down. And here in acceleration time graph, because it is negative of sine omega t, so first it goes down, then up. Okay, example for SHM is a simple pendulum. And remember, um, uh, this simple pendulum must have a point-sized object and a flexible, inelastic, perfectly elastic and inextensible string with a rigid support. So if anything satisfies these conditions, then it will be a simple pendulum, which so ideally these conditions are not possible, but anything which is close to it, then it will be considered as simple pendulum. So if you have a heavy object, then it will be considered as simple pendulum, but for that purpose this thread should be quite long. This should have bigger size. So okay, if it is oscillating, So at any moment, its weight mg going downward, and so we will resolve it in along two direction, one along the thread, other perpendicular to it. So if this angle is theta instantaneously, then this is also theta, this is mg cos theta, this is mg sin theta. And okay, I haven't told you the origin of SHM. So for SHM, some f equal to minus k x or y, whatever, some displacement is there. So this is called restoring force. So restoring force is required. Okay, so here this mg sin theta acts as restoring force. So don't write this right now. I have just mentioned it in order to recall that SHM requires restoring force. So we can start from here. So restoring force, in this case, F is equal to minus mg sin theta. So minus because restoring force, it restores, it is opposite to the displacement. Where is displacement here? Okay, so for that, what we have to do, let us suppose this is x displacement, and this is L pendulum length. So okay, now there are two conditions. So this sine theta, if this sine theta, if theta tends to 0, means it is very small, then sine theta approximately equal to theta. So we have to directly replace f equal to minus mg and theta. And here we'll put okay, so f equal to ma equal to minus mg and theta. So angle equal to arc upon radius, angle equal to arc upon radius. So here arc is this x. For very small value we can consider it as x, and radius is L. So now we can see a equal to minus g upon L, as m has got cancelled, multiplied by x. So here we have seen that in simple harmonic motion, a is equal to this a sine omega t, which is y, a equal to minus omega square y or x, whatever, but displacement, acceleration, displacement, and the remaining is omega square. So same will be here, comparing it with a equal to minus omega square x. So we can say omega square equal to g by L. So omega equal to root g by L. So omega is 2 pi, nu is equal to root g by L. So nu equal to 1 upon 2 pi root g by L. And so time period, which is reciprocal to frequency, is 2 pi root L by G. It is directly proportional to length. If we increase length, then time period will also increase, and inversely proportional to acceleration due to gravity. The bottom line is, it is independent of mass, but mass is required because it requires inertia to move here and there. So mass is required for oscillation, but time period does not depend on mass of pendulum actually. Similar thing happens with the loaded spring or horizontal spring. So we will just discuss about how it works. This motion does not involve its weight because it is already balanced by elastic effect of this spring. So here directly f is equal to minus ky. We can write x or y, whatever, but logically this is y direction, so I am writing it minus ky, and then ma is equal to minus ky, so a equal to minus k by m y, and as we know that we will compare it with omega square y because it is the standard form of simple harmonic motion. So omega square equal to root of k by m, which depends upon mass. So pendulum does not pendulum time period of pendulum does not depend upon mass, but loaded spring, its time period depend upon mass. Oh, sorry. Right now it is k by m, and then omega equal to root k by m, and then omega is 2 pi nu is root k by m. So nu equal to 1 by 2 pi root k by m, and time period you can find by reciprocating this. Now, conservation of energy by simple harmonic motion. So we know that kinetic energy is equal to half mv square. Okay, now here what is v? So just memorize this. V is equal to omega root a square minus x square or y square. So remember this, v equal to omega root a square minus y square. We can derive it, but directly memorize it. Okay, so we'll put it here. So kinetic energy is equal to half m v square, means square of this means omega square, and root will get cancelled because we will take a square of it. So it will be a square minus y square. So finally it will be kinetic energy equal to half m omega square a square minus y square. I'm writing it again and again. Okay, I don't know. Okay, so next is potential energy. So potential energy is actually the work done, negative work done, of course. Okay, y, because it is y, and within limit 0 to y, it doesn't matter. So f is because it is restoring force, so f equal to minus ky. So minus of k y dy limit 0 to y, so it will be positive, and then k y dy is y square by 2, because of that integration rule, y to the power n d y equal to y n plus 1 upon n plus 1. So it is half k y square. Now what is this k? We know, we have done it many times. Omega square equal to k by m. So this k is actually m omega square. So this potential energy is equal to half m omega square y square, and that's all. Now total energy E will be kinetic energy plus potential energy, so that will be half m omega square a square minus y square, and plus half m omega square y square. If we add both of them, then m omega square will taken as common, a square minus y square plus y square, it will get cancelled, so final will be half m omega square a square, which is constant. So that verifies law of conservation of energy, and it also tells what is the energy of SHM, or any body which is performing SHM. Next is, I'm not going to derive it. For derivation you can watch other video of mine, but here what is important, that in some of the question you need to have just an idea of plane progressive harmonic wave. So plane progressive harmonic transverse wave. So it's wave oscillating along y-axis and propagating along x-axis, positive x-axis, of course. So its equation will look like this. All right, so this is y, this is actually x-axis, and at different phases we can see this. So its most probable equation is y equal to a sine a's amplitude, y is equal to a sine omega t minus kx, or in a different manner it can be also written as y equal to a sine kx minus omega t. It is just a matter of reference, with which we are observing this wave. But I'm not saying that this can be converted into this or vice versa. No, I'm saying that this equation can be expressed in terms of this form or this form. Actually, this wave pattern, it is at a particular phase, at a particular time. At very next time, it would change its form. Maybe it would start from here then, and maybe next one would go like this, and so on and so forth. So actually, it goes in 3 dimension, and we have restriction for 2 dimensions only. So time dimension we can't draw. So that is why if uh, we consider it at a particular phase, then we can express it in terms of this equation or this equation. So and once again, I'm giving disclaimer. I'm not saying that this and this both are equal, but I'm saying that both forms are correct. Either the question would be asked in this form or this form. And also, wave can also start from here. So the same wave can be, this plane progressive harmonic wave can also be given as y equal to a cos omega t minus kx, or y equal to a cos kx minus omega t. Sometimes plus phi or minus phi is also there. Sometime sine term and plus cos term is also possible. So generally, this amplitude in terms of this plane progressive wave, in terms of a mechanical disturbance, which is going this way, if we, shook a string, so wave propagates like this. In those cases, y is measured in meter, amplitude is measured in meter, omega is angular velocity, omega equal to angular frequency rather, 2 pi nu, which can also be given as 2 pi by t. And k is not this k, it is for SHM. Here for this wave, k is propagation constant, which is 2 pi by lambda. Lambda is wavelength from here till here, the distance from here to here. This is lambda. So okay, few more things. Speed of wave equal to speed of wave v equal to nu lambda, and also omega by k. If omega and k is given, then directly you can write this. Otherwise, from these formulae, you can find nu and lambda, and then you can put it here also. So electromagnetic waves are also transverse wave, and the electromagnetic waves carry pulsating electric field and pulsating magnetic field. So if there is an electromagnetic wave which is propagating along positive x-axis, whose electric field is oscillating along y-axis, within y-axis it will go to positive y, then negative y also, and its magnetic field is oscillating about z-axis. So this is a 3D view. So imagine it as a corner of your room. So this is x, and wall is y, and floor is z. So magnetic field is given by B, electric field is given by E. I'm not confusing you by introducing new things, but okay, yeah, you can write y equal to or z equal to, no problem. But in terms of, oh sorry, these are amplitude, so we'll put small 0 in as a subscript. So for electric field, E equal to E naught sine omega t minus kx, or it can be E naught, this is not epsilon naught, You probably heard it is E naught. It is amplitude of electric field. This is general electric field at any instant, and this is peak value or amplitude of electric field. Amplitude. Okay. E naught sine kx minus omega t is also possible, and similarly E naught cos omega t minus kx is possible, and also E naught cos kx minus omega t is also possible. So all of these forms, and similarly b equal to b naught sine omega t minus kx, and so on and so forth. So this is how electromagnetic wave equation goes like. And here also omega is same thing, 2 pi by t, and k is same thing, 2 pi by lambda. That's all. So let us suppose this is a question and they have asked direction of propagation, okay, then amplitude, then propagation constant, then uh, angular frequency, or wavelength, uh, and frequency. Okay, so direction of propagation. Remember, if there is minus in between both of these, then the direction of propagation is positive of what? Of the axis given in this bracket, that is z. So it is positive z axis. Amplitude 40. I haven't mentioned the unit of displacement here. So let us suppose it is in SI units, so 40 meter. Propagation constant, so we know that this T term has this multiple which is omega. So other, this coordinate term will have a multiple which is k. So propagation constant k is 360. Oh, I forgot to tell you that its unit is radian per meter, or simply per meter, because it is 2 pi by lambda. So lambda is in meter, so radian per meter, or simply you can write per meter. And angular frequency, so this is omega angular frequency 20, and its unit is radian per second, or you can directly write per second. And if they ask about wavelength and frequencies, we can calculate from here. So we know that k equal to 2 pi by lambda, so lambda equal to 2 pi by k, that is 2 pi by 360. You can solve it, or you can directly write meter here. And frequency is we know that omega equal to 2 pi nu, so here it is nu equal to 2 pi by omega, and due to which oh, sorry, a slight mistake. Omega by 2 pi. Omega by 2 pi. And omega is 20 upon 2 pi. You can solve it, or up to a certain level you can, okay, like this, 180. So pi by 180 meter up, and here 10 by pi hertz. That's all.